Assalamu alaikum everyone. I am Mohammad Zaim Javed and along with my group partners, I will discuss the challenge of identifying historic private browsing sessions on suspect devices. Private browsing is a privacy feature available in many web browsers. During private browsing, internet history is not maintained and local data related to such a session such as cookies are cleared when the session is closed. Private browsing has its benefits, but it can be used to avoid internet browsing history logging while performing any illegal or immoral activities, thus raising privacy and security concerns. In this paper, the researchers have focused on the detection of private browsing by those individuals who were ordered to maintain and present their browsing history after regular intervals by the court under the Sexual Harm Prevention Order (SHPO) imposed in England and Wales. Problem targeted private browsing data poses an investigatory challenge in the case of SHPOs. Detecting when an offender has initiated a private browsing session can be valuable evidence of a violation of SHPO for the law enforcement agencies. This work examines the challenges of detecting when private browsing sessions have been initiated on a device. Different methods of live system monitoring are discussed. Methodology used. Windows Sys Internal Process Monitor was used on a test environment running Edge browser and Windows 10 OS to identify file system and registry artifacts when a private browsing session was started and ended. Researchers were unable to identify any related operating system and registry artifacts, revealing that information regarding the history of private browsing is not stored on the system, so dead box analysis in such a case is not a good choice, whereas live monitoring of a system by installing or configuring an application on a system is an effective method that may reveal malicious user behavior in greater detail. Two tools, Windows App Locker and Private Spy, are used to perform live monitoring of a system as discussed further. Windows App Locker is a built-in tool present in various versions of Microsoft operating system. For live monitoring of a system, we can configure it to the audit mode. This mode gives us the freedom to use the system while it runs in the background. In the audit mode, it generates logs for exe and DLL execution found by using the Event Viewer application. We can compare the log entries generated for the execution of different web browsers by the App Locker with the history maintained by the corresponding web browser. For a private browsing session initiation, a log entry for the execution of the browser would be present in the AppLocker log, but the browser would not maintain the corresponding history for such a browsing session. Here we can see the detection mechanism used by the AppLocker in a pictorial form. Limitations of using AppLocker. AppLocker rule enforcement feature is not supported in some of the Windows OS versions. AppLocker can't differentiate between an actual private browsing session and a scenario where a user accidentally opened a private browser and closed it without browsing. Lastly, when someone concurrently browses normally and privately, in such a case, AppLocker and browser activity correlation would suggest a normal browsing mode, thus hiding the private browsing session activity. The researchers have developed a tool named Private Spy, a Python framework developed to monitor a system in real time to detect the presence of private browsing windows. Private Spy is designed to detect Edge, Chrome, and Firefox private window occurrences and log the time and date for such an event. Windows identification. Edge, Chrome, and Firefox private windows all have customized Windows label as shown in the given figure. Private Spy monitors the system for browsing Windows presence using Python's Win32 GUI.find window X method. Detection of Firefox and Edge browser private windows is easy as their normal and private browsing windows labels are different, whereas Chrome has the same label for normal and private browsing windows. Google Search homepage is a non-configurable homepage for Google Chrome, so whenever a new normal Chrome window is opened, the browser either downloads the required elements for the page or re-accesses them from the browser cache. As a result, the time between the execution of the normal Chrome window and the entry creation re-access of the browser cache is a fraction of a second. In comparison, when a private browsing window is created, No cache content is created or accessed, therefore creating a time difference between the new tab window creation event and the cache content creation or re-access event. If this difference is greater than 1 second, it indicates that a private browsing window was created for Google Chrome. Here we can see that for Chrome incognito mode there has been no change in browser cache, whereas for Chrome normal mode there has been a change in browser cache. Also in the second figure we can see that time difference between the last update for Google Chrome's cache and the event for new tab creation of Google Chrome. Strengths of the given paper: detection of private browsing through live monitoring of the system is proposed through two different tools. AppLocker can provide a partial insight but does not offer a complete solution. A customized solution, Private Spy, is proposed for the detection of private browsing within an SHPO context. Access to the customized solution Private Spy is not provided by the author, so we could not explore the given tool. Private Spy is only tested on Windows 10. It should be tested on different real-time scenarios and the results should be shared publicly. Similarly, exploration and comparison of both the tools should be made on different version of Windows operating system and different other operating systems. Thank you all for listening.